end of the speakers, and Øyvind will help moderate that, and together with myself. But I would like to just to emphasize that, you know, this smart shipping is becoming more and more important, and the use of digital technology, and we're benefiting from the a lot of effort in Industry 4.0, and I think that has helped kickstart a lot of the digitalization efforts in the maritime sector. So without waiting any longer, I'd like to invite Dr. Øyvind to give us a sense of the R&D roadmap that was developed between Sintef Ocean and TCOMS and was launched a couple of weeks ago at the SMI forum. Over to you, Øyvind.
Thank you, Sanjay. I'll be quite excited to share this with you. We've been trying to sort of dig one step deeper from the R&D maritime roadmap for Singapore developed by SMI and MPA on the maritime transformation. Autonomy, of course, is a very central area in that more wide roadmap. And then the two institutions, Sintef Ocean and TCOMS, we gave ourselves the challenge of trying to dig a bit deeper into that and develop a specific roadmap in the area of smart and autonomous shipping. So if you can see my screen now, then you can, good. Then I'll start walking through this very briefly. There's a lot of text and there's a lot of reading in this, but I invite you to download the written version from the websites of TCOMS or Sintef Ocean and use that as a supplement and reference for later on. So what we were trying to do was to identify what were the critical areas for smart and autonomous transport systems and to create a document for synergizing and get various stakeholders on board and get various technology developers into the same frame of thinking and perhaps come into a setting where each would then focus on their separate speciality, and then the totality of this would be a vehicle for moving the whole energy forward. So together with MPA, SMI, the Research Council of Norway, TCOMS and Sintef sat down through a series of workshops to formulate what we saw as the main areas of this coming development, and to be able to share and communicate a common picture of development needs in that area. We tried to formulate a very tabloid status description. Where are we today? Where do we want to go in a given time perspective? And then tried to formulate which were the necessary development, research and innovation projects required to move the industry from present status onto this projected targeted future. So the next slide is the complete roadmap. As you can see, it's extremely busy. It's a lot of information in this. And what I thought I'd do in this presentation is to take you through each of these areas on the left-hand column, and then discuss a bit on each of these areas, what then forms the R&I projects that we have projected in this middle part of this roadmap. So this, as any kind of roadmap, the question is whether the roadmap or the process is the most important one. But I believe that a common roadmap like this also could have quite a lot of interest, and it is a backdrop for sharing out development processes and projects between many different actors worldwide. So the main areas, when we started looking into this, it was actually quite easy to come up with a kind of consensus description of what were the dominating areas. Of course, rules and regulations are totally critical in order to make such a change for the industry. International regulations, regional regulations, local regulations, and especially if you're looking at the world trade, then this process towards common unified rules opening for autonomy for deep sea shipping could be the most challenging one. But then rules and regulations definite has to have a large focus with respect to further developments. And then the information exchange between vessels, between ship and shore, between different remote control centers onshore, vessel traffic services onshore. So this whole picture of streamlined automated information exchange is extremely interesting and important to move forward. Then of course smart ships, which in effect is just what the industry has already been doing. There's a lot of automation continuously being done. There's a lot of improvements continuously being implemented without really taking the step to a full autonomy. So the further development of smarter shipping is definitely a key area. And then you have this whole picture of autonomous ships, which might be a complete change of paradigm for shipping, changing the, let's say, the focus from the ship owner, ship operator to the cargo owner, if taken to the fullest extent. Then, of course, autonomy in shipping cannot be realized without the further development within the ports and further development within all the relevant ports. Now we see a big difference between the most advanced ports and forward-looking ports like Singapore, ports in other countries where really haven't taken this seriously to the same extent. And then of course ship physics, without understanding how a ship behaves, we're not getting any further. Technical operations is important. And then finally, this innovation ecosystem, which if we take this transition to the full extent, then this might open for a completely new level of services offered to the industry. So I just thought I'll sketch for each of these areas just one slide to highlight a bit which are the main areas or activities, developments that are needed in order to move us from what we see today as a kind of prescriptive minimum on the rules and regulations to actual rules supporting autonomy. Sanjay, can you confirm whether you see my mouse, my pointer?
Yes, I do.
Okay,
but
excellent.
I have to really, don't move it too fast. I think the slower you move it, the easier it is to see.
Okay, perfect. Thank you. And then, of course, the work on regulations would be totally critical. And I think the main mover, or we believe that the main mover in the immediate future will be the national or the regional regulations. Because what happens nationally, there's much larger freedom, and perhaps even a larger impact of what is done and can be done on national level. And then that will in turn spill over onto the international arena in due time. So what is done by nations with respect to preparing for autonomous shipping is perhaps the main driver, and then the international processes have to take a bit longer time, but will come forward and will be the, let's say, the formal basis in the future. The rules for interaction between autonomous ships and conventional vessels, there has to be a very strict basis to avoid miscommunication and to make sure that the right information is transferred. How it should be done, what should be transferred, how it should be done in order to be properly understood and acted on from both sides is critical. And then we need methods for test and verifying that this is actually working the way we want it to do. We need to have to define the proper acceptance criteria, and we need to have proper procedures for approval and certification. Each of these steps, they seem self-evident, but behind each of these small steps actually lies quite a significant piece of work in order to come up with rational and effective measures and procedures. And of course, even if you're looking at autonomous vessels, then human factors will play an important role, perhaps even more important, since quite a few operations will have to be done remotely. And training of operators will be critical. How to transfer the understanding of what's happening on board properly to a person sitting at a desk many kilometers away. How to make this work in practice is not self-evident, and it will need quite a bit of effort in order to come up with a proven, reliable, social accepted regime. Then the information exchange in itself is a critical area, but this one is perhaps the area that receives most attention by itself. This is where all the cybernetics people dive in and find that this is where they can put all their knowledge to work in a new area. This is where all the companies working on smart shipping see that this is the logical next step. They can use all the wonderful tools and equipment they have. So it's an impressive push and an impressive development in this area. And then the market take-up is different. Advanced ports, advanced areas are very much accepting, pushing, encouraging. Others are more passive viewers to this. So this is an area where I think there's a huge technology push, and whether the relevant pull is there at the same time, I'm not really certain. But again, totally critical area, and key to the success of autonomous shipping. Security being critical in this, but also all this work about really defining exactly what are the processes that should be standardized. Smart ships. This is the development that shipping is part of almost anyway. You can draw this timeline at the bottom from the 1800s with mechanical power, mass production of diesel engines, computerized control, and then shipping 4.0 coming. So the developments within smart ships, that's something that the industry is well used to, accustomed to. They've been reaping benefits from this for decades and centuries, and it's not going to stop. Autonomy or no autonomy, the development of smarter ships, more intelligent vessels, more intelligent communication is just the way this whole industry is moving. And looking at this general part here, it's moving from ship as a separate entity more and more towards ship and shore in cooperation, and ship or as a part of a fleet or as a part of a complete logistic systems. Then the difference from autonomous ships, moving from manual ship operations to more and more of an automated transport and logistics system. Remote control centers for each ship owner, fleet operator, local control centers in each of the major trading hubs, local services supporting the remote control centers. The whole, bless you, different way of setting up offices, setting up the internal communications. Then, of course, sensor systems on board ships between or the aids to navigation, collision avoidance, and automation of a lot of the operational parts, automation in harbors, tugs, anchor handling, cargo handling. There's a whole range of developments that have started, are underway. It's not for many of these areas, it's not fair to say that this is something we see coming in the future. A lot of this is already well underway and has reached a piloting stage in quite interesting areas. And then, of course, the ports are the key to harvesting the full benefits of autonomy. And then I think it's fair to say that in general, there is a low ship-to-port automation. Singapore is perhaps an exception in that. But then moving the whole trade to automated port-ship interaction, that would take quite a bit longer time. But then automation of the port state control, perhaps what's most important is this planning of just-in-time arrivals, good traffic control, traffic management systems, co-automation of ship and port, digital ports, and then automation of the different operations. Ship physics, digital twins, open simulation platforms, models for operation, models for ship-shore interaction, moving from a conventional discipline focus to a more holistic ship design approach. Technical operations will have to involve a new paradigm for maintenance, since the ship will not be manned en route. The people going on continuously checking, double checking, doing all the smaller stuff will no longer be there. So the whole thinking of technical operation will need to be redone. And then finally, last but not least, is this possibility this may offer for new businesses. This picture, this illustration here, we have 6 billion phones with just 2 operating systems. This small orange dot here represents the vessels we are talking about. and all of them have their different ICT systems. So there's obviously a possibility for standardization, there's a possibility for new services, there's a possibility for new companies moving into this new world. At present, we see a very high threshold for new service companies entering the scene. There is a potential with this transition to autonomous vessels that a totally new and open innovation system can be established. So to bring you back to this overall roadmap, what you see on this slide is the entire content of my presentation so far, where you have stacked out these different areas or developments where the hope is that technology developers can say that, okay, this box in the middle, this is where I really can make a difference. And then I can work on this other box down here. But then I know another company who's very good at this box down there and the other down to the right. And if we all move together and focus in on where each of us can really make a difference, having such a common perspective of how to move forward could then be a very valuable tool for coordinating information and for coordinating development projects in future. So this was a very fast recollection or run through of a quite extensive work. I encourage all of you to download the full version of this roadmap from the websites of Sintef or TCOMS. And then on behalf of Sintef and TCOMS, I would really like to thank MPA, SMI and A-Star for their support in this work, and also Innovation Norway, the Norwegian Embassy, and the Research Council of Norway. Contacts are listed there, and encourage everyone to take contact and discuss further if this is of interest to you.
Thank you very much, Øyvind. It's amazing how we started this a year ago at the North Shipping in Oslo when we signed the MOU, and we've got this far, and I hope this will be used further to really kind of crystallize the key research areas where both countries can really cooperate, and the universities across the two nations as well. So I think in leading up to that, I think it's good to have an understanding of the capabilities on both sides of Singapore and Norway in terms of research capabilities. And just to start us off is Prof. Allan Magee. He's a professor of practice from NUS, and he spent 16 years in TCOMS. So he started from the hard part of the equation, knowing all the problems that it's going through. And now he's the director of operations at TCOMS, and he's intimately involved with our Center of Excellence for Autonomous and Remote Operations, COPS. Allan, welcome this afternoon, and looking forward to your sharing. Over to you, Allan.
Okay. Per, are you able to pull up the slides?
I can. Hi, Allan. My computer was actually collapsing today.
Oh, okay.
So I'm on a backup computer. But do you have a chance to do it yourself, or should I try?
Yeah, I can do. But I just think the bandwidth may be a little bit slow, so we'll see what we can out of this. Then yeah. I need to share my screen. Is that working?
Let's see. I don't see anything yet.
Don't see it yet. Okay. Share. Okay, hang on 1 sec. There we go.
Yep, we see it now.
Okay. Right. So with that introduction, great overview from Øyvind. Then my presentation actually will drill down into some of the technical details involved in the development of digital twins. And I'm sure you understand that these are essential component in order to enable eventually autonomous and remote operations for vessels at sea. So just a little background. TCOMS actually started off about almost 5 years ago and was formed as a national center to support the marine and offshore industry with support from all the Singapore ecosystem. And so TCOM's job is to solve real-world problems and to help testbed next-generation solutions together with the marine and offshore industry. So some of the enabling technologies, emerging technologies, which can help transform the marine and offshore industries are shown on the left. So things like data science, machine learning, smart sensing, automation, robotics, all these things are, as Øyvind pointed out, are making a transition in the marine industry. So some of the drivers, 5 years ago, oil and gas was still an important, although it has, I'd say, reduced somewhat in that respect, but still an important aspect for the Singapore ecosystem. Plus all of the skills and all of the know-how that we have developed over the years, including many years in the oil and gas industry, they are quite applicable to many types of systems in the sea, and future systems coming up will, I think, make use of the same know-how and experience as well. So we're mapping these technologies to help with the transformation into the next generation of ocean systems. You can see on the right side. So a key component of TCOMS is the ocean basin, which is one of the largest in the world. I think second maybe to Sintef Ocean in Norway. It has a movable floor with a central pit that can go down to 50 meters water depth, so we can simulate deep water risers. It has an XY towing carriage, which can be used for towing and maneuvering simulations. And then we can generate waves and currents in different combinations to simulate the conditions at sea. So this is quite flexible and useful for all kinds of studies related to vessels as well as other structures floating in the sea. So as mentioned, Singapore is getting ready for the introduction of what we call MAS, Maritime Autonomous Surface Vessels or surface ships. And so TCOMS is working in connection with MPA, and the Singapore Maritime Roadmap includes a task on smart fleet operations and autonomous vessels. So TCOMS is working together with them. We know that Singapore's port is one of the busiest in the world. Some of the largest and the most advanced ships call here frequently. So Singapore has to be ready for the introduction of these new smart vessels and their technologies that are needed. So COPS was formed to start looking at these issues. So COPS is the Center of Excellence for Autonomous and Remotely Operated Vessels, which is hosted by TCOMS. So we're mainly working in 3 key areas. First is to build a high fidelity model of the physical operating environment, starting with the port waters around Singapore and the entrance, so that we can understand the environment that's operating. At the same time, there will be a lot of vessels entering this area. So in order to make those vessels safer and more efficient, we need to understand how they behave better and be able to predict things like vessel interactions in very tight operating environment around Singapore Straits. At the same time, we need to have some capability to assess the structural health of the vessels as they sail. And this will become more challenging with reduced manning. And so a lot of operators are looking at smart technology monitoring systems which can actually enhance the safety and reduce the need for frequent periodic inspections. So this can make the ships more economical as well as safer over time. So these are the three things that I will focus on a little bit more details in the presentation. So thinking about autonomous navigation, here you see a shipmaster navigating in rough seas in the North Sea, a winter storm. This is a search and rescue vessel, and you can see that he's actively controlling the vessel. So he's looking at the waves and he's trying to understand the behavior of his vessel. So he's feeling it with his feet, with his own internal accelerometers, to understand and predict the behavior of the vessel, and then to maneuver it safely through the rough weather. So how can we achieve this level of experience and good seamanship using an autonomous vessel? That's a very big challenge, and I think there are a lot of ship physics that need to be understood in order to reach that point. So this is what some of the work that we've been carrying out in TCOMS, how to build a captain's experience, knowing that if you have an autonomous car, the environmental loads are relatively small, whereas if you have the ship in the upper frame operating in large waves, you can see that the inertial loading is very important and needs to be included in the model of the autonomous vessel. So, and also ships, they take a long distance and time to maneuver. So up on the right, you can see the effect of the current on a container ship executing a turning circle. On the left, you see the effect of a 1.5 knot current, which you might experience in Singapore. So again, a captain on board today, he's well aware of the situation and he's able to make corrections and through experience maneuver safely. But in order for the autonomous vessel to capture that behavior, then we need to understand a lot better how ships behave and also the effect of the environment. So part of the development involves building a so-called digital twin of the hydrodynamic environment. So this would take as input some of the global weather models for boundary conditions, and then provide simulations of environmental conditions around Singapore, and eventually heading out into the South China Sea and perhaps other areas. So this could be useful for predicting, for example, is there a strong current today? How will that affect the vessel behavior as it enters into this very tight environment, so that we don't get any surprises or unexpected behavior. This will be especially important when we have a mixture of autonomous and conventional vessels all operating in very close quarters. So the physical model then will feed into the digital hydrodynamic twin of the vessel to understand how it responds to the effects of the external environment. So we've been building hydrodynamic models for various types of vessels based on computational fluid dynamics. So these are very large-scale simulations that take place on the National Supercomputer Cluster. So they're really too vast and too slow for real-time controls. So the way that we manage this is we build data-driven or reduced-order models that capture the essential behavior in a few lines of code. And then this can then predict and be used to control the vessel under the influence of complex environment that we saw in the previous slide. So effects of vessel maneuverability, the interaction of hulls and thrusters, and maneuverability in calm water as well as in waves. So this is one of the big areas that TCOMS and Sintef Ocean have been working together for quite some time now. As I mentioned, with reduced manning on board, you don't have people to understand the condition of the vessel. So how can we make sure that it's safe after a storm goes past? Do we need to make repairs, or is it still safe to go on? Can we continue safely? So this will require some onboard sensors to monitor the vessel behavior, as well as what we call a digital structural twin, which can predict the stresses throughout the structure based on a limited number of measurements. This can also help with long-term fatigue monitoring and provisions for dry docking, so that we can know what areas to inspect first, which should be the priority, depending on what seas and loads the vessel has experienced during its sailing. So just to sum up then, the digital twin, it couples a virtual and physical replica of the real world system. It uses monitoring and prediction to enhance the understanding of the vessel behavior in harsh environments and in day-to-day operations. So it can be used for optimization, for validation of different monitoring systems. It can also be used to help improve the operation. So, for example, if we can capture best practices from some of those experienced seamen, then we can perhaps gain knowledge about how to maneuver safely in more harsh environments, or how to perhaps operate more efficiently over time. So all of this requires a much better understanding than the conventional engineering that's used to design ships today. So TCOMS and Sintef Ocean will continue, I think, on this journey for some time to drill down and really develop the tools that are needed to enable this technology going forward. Okay, thank you.
Thank you very much, Allan. That was very, very informative and exciting. And you know, you mentioned digital twins, and our next speaker, Prof. Chu, is the Center of Director for the Center for Next Generation Port. And this Center of Excellence is one of the 4 centers of excellence that SMI has funded. COPS was one. And they are very much into the thick of digital twins as well, especially with the Tuas port development. So I'll let Prof. Chu bring us in. Prof. Chu, over to you.
Okay, thank you. Let me first share the screen, share the slide. Are you able to see it?
Yes.
Yes,
okay.
yes.
Okay, good afternoon. So I'll be sharing on the topics on next generation ports. So what features should next generation ports have? So there is a general agreement that the next generation ports should address 4 areas. Okay, the first one is on green and sustainability. So generally in the area of decarbonization, replacing fossil fuels with renewable energies, and also land intensification. Automation, that is a port should be fully mechanized and automated, as well as autonomous. We are using driverless vehicle. And finally, digitalization for building smart and intelligent process. So, like, what happened?
Hold on.
Somebody is trying to share.
Is that, no, that's not you, right?
No, it's, okay, let me try to share again. Okay, so in this talk, okay, I will focus my discussion on digitalization, especially in the area of digital twin, which are just now. But this is more in terms of the next generation ports. And of course, we know that Industry 4.0 has made it possible for this kind of digital transformation. So I'm sure many of you know what is a digital twin. So it's actually the digital manifestation of physical systems. And in order to be able to build a digital twin of the port, we will need to model the actual dynamic behavior of the port, and hence the understanding of the port processes and the operation strategy, how they interact with each other, and the events taking place are necessary. So I'm sure many of you also know why digital twin is used. Of course, one of the things that we have learned over the past is that due to Industry 4.0 is an enabler, and so it's a key for digital transformation of many industries, and it's also getting increasingly popular as it's seen to drive many innovative solutions and to increase performance and profitability. So the drivers, of course, that supports digital twin development are because today we can see that there's greater connectivity with more sensing through the IoT, cheaper and faster computing and storage, allowing for more powerful analysis and operational improvement, as well as faster communication, like the newly technology introduced in the 5G environment. And with new automation technology, like Internet of Things, data, big data, and also use of artificial intelligence are also important enablers to create a digital twin which can help the next generation ports to be efficient and smart. So we know that there are many perspectives of what a digital twin is. Of course, just now, Allan has also shared his part of the digital twin. So as we can see from all the understanding that we have, a digital twin could be just a simple 3D model with IoT and shows the information of the system state, or in a more advanced model, data is collected to be used to describe the behavior of the system. Where just now what Allan had mentioned about collecting data to understand the dynamics of the system and then learn from there. So where machine learning are applied to the historical data to provide information on future trend. There are also models that combine data and logical process activities to better describe the behavior of the system. Whatever it is, when developing a digital twin, it has to be purpose-driven. The level of fidelity also plays an important consideration when building a digital twin to ensure that it is computationally feasible to enable a decision to be made. So it should not just be a twin, but many twins for the same system, and it depends on the purpose. For example, if you can see, there are various activities when you design a digital twin. It could be for design, for planning the operations, for daily operations. So each of them have different purposes. And depending on the purpose, the fidelity level can be low or it can be high, right? So essentially, that's what I want to make mention is that, we don't just build a twin, but there will be many twins depending on the kind of study or the purpose that we want to have this digital twin perform. One of the opportunities in having a digital twin is in the area of simulation analytics. So in the physical world, we know that we are bounded by space and time, and also the type of data that we can use to learn. But in a digital twin, these boundaries can be relaxed, and we can perform many types of scenarios, which some of them have not happened yet. Moreover, we are not bounded by time, and we can get the answer within a short time. Usually, when we try to understand the future trend, we use machine learning tool, for example, to regress on the historical data to determine the pattern. However, it will not be able to extrapolate accurately if the points are beyond the limits. It will only work well within the limits of the historical data. So this is where the digital twin can help, as it is not only able to learn from historical data, but it has the capability to generate scenarios that have not happened before. Learning only from the historical data will not be effective because this method is reactive, and this type of learning have a lag effect. So it means that we are always chasing after the solution. The digital twin solution can actually help to address this because it makes the system anticipative by generating likely scenarios and evaluate the impacts of these scenarios before they can happen. So in summary, the digital twin takes information from the historical data and current data from IoT and TOS, the terminal operating system, to show the system states and the impact if the certain decisions are taken. It can also generate future optimized data from the scenarios generated from the digital twin. From these sources of data, they can go into a learning model to map the optimal decision space with different scenarios. This optimal decision space will be the super brain that can provide feedback to the decision makers with these scenarios that has happened. Hence, we are actually learning from the future for the future. So by using simulation analytics, the digital twin will be able to work hand in hand with the physical system to help the next generation pod to be efficient and intelligent. As mentioned by Dr. Sanjay Kutan, we have actually a Center of Excellence in Modeling and Simulation for the Next Generation Pod, or C4NGP in short, to take up the challenge of developing this pod digital twin. So C4NGP, as mentioned, is supported by the Singapore Maritime Institute, a government funding agency which has developed the Singapore Maritime R&D Roadmaps 2030 to identify capabilities needed to ensure Singapore's long-term competitiveness in the maritime space. So C4NGP has developed an open source simulation platform called the OJES, which is embedded with simulation optimization technology. Our digital twin will be built on this platform. Besides using the discrete event simulation as the modeling technique, we have also embedded simulation optimization technology in the platform. They are the optimization in simulation, simulation optimization, and simulation analytics. Each optimization engine has its role to play. For example, optimization in simulation optimizes on the best operation strategies to be used. The simulation optimization helps to identify the best design configuration, and the simulation analytics helps to make decisions in real-time operations. So our digital twin will sit on top of this platform, and it will be supported by visualization, such as a dashboard and 2D or 3D models to give insightful information. In addition, on the right side, if you see, we're also creating what I call a pod ML, which is a universal markup machine language that can specify the configuration of the pod. And by doing that, actually, you can help to accelerate the model building of the pod digital twin. So I would like to share with you two of our recent C4NGP initiative. The first initiative is the PodML standard, which I just mentioned is a set of universal markup programming language to configuration of the pods. So in order to establish it as a standard, we have recently set up a PodML Alliance. The PodML Alliance will comprise of academia and researchers, developers, companies from the port and maritime industry, and port authorities. With this critical mass, the PodML Alliance will seek to push this markup language to be adopted as a new international port and maritime machine language standard supported by international organizations such as ISO or the United Nations. Here is the example of a PodML standard, which shows the markup language to describe a yacht block. So this is essentially what we are trying to push this standard. And of course, there are benefits by pushing these standards. First is that it can help to accelerate the building of the pod digital twin, and hence cutting down on time and will improve labor efficiency and reduce operating costs. Second, it will establish a common working platform to enable compatibility among all stakeholders in building digital twins in the maritime and port industry. And the third one, which is very useful, is that it allows portability across different digital twin platforms. The second initiative is the Singapore Studio. The Singapore Studio is our in-house built software tool to support the model building of the digital twin model with user-friendly interfaces. It contains libraries of pod modules interfaced with the O2 platform and built around the PodML standard. It is scalable. For example, for the digital twin of one of the fingers in Tuas, it takes 5 minutes to compute for one simulation day, which contains millions of events to run. So Singapore Studio also allows digital twin to be built at different level of fidelity. For example, like a key crane, you can actually model the actual by looking at the actual movement of the straddle, the acceleration, the deceleration, the actual dynamics of it. On the other hand, you can also model the key crane as just this distribution of a cycle time of loading and unloading. So it can have a high fidelity and low fidelity level as well. Third the single port studio is built on to be efficient, and as the modules are detachable, reusable, and reconfigurable, it allows the digital twin to be built faster. It's also designed not only to evaluate design, but it's able to find the optimal or good design. As mentioned, that the Singapore studio is built around the port ML standard. It is able to read a port ML of a port and convert it into the port digital twin. And if the port digital twin is built by the Singapore studio, it will be able to convert it to the port ML of that port. So I think this is the end of my presentation. So thank you.
Thank you very much, Prof. Chu. That was I'm always intrigued by the ability to converge the algorithm in such a complex data input in a very short time. It's very exciting times for situational analysis. Per Krista, is Thomas on line, or shall we move to?
Yes, I think I saw Thomas coming in. Yeah.
Great, Thomas, welcome. Yeah, so Thomas Ting is the Deputy Director of at the MPA in the Division of Innovation, Tech and Talent Development. Thomas has 20 years actually in the maritime sector, and he's a proud alumni of SMI. He spent 3 years at SMI, and I guess his MPA is really committed to this whole transformation of the maritime sector, not only for Singapore, but also participating at the global level through IMO and a lot of regional and international initiatives. So very much an involved agency at the global stage and not just at the local ecosystem. So over to you, Thomas.
Yeah, thank you, Sanjay. Good afternoon, everyone. Good to see a lot of our friends from the Singapore and the Norway research community. And my apology to Prof. Chu and the co-chair just now. I think too eager to share my slides too early. But anyway, the topics I'll be sharing today is on the maritime autonomous shipping in relation to the port development in Singapore. I'll move on. I think all of us agree that there's been a lot of discussion and momentums relating to autonomous shipping globally, driven by industry players and also by a country setting aside test bidding activities for companies to do trials. My observation is that a lot of these trials focus a lot on autonomous navigation, not too different from what the cars are doing on the road. But I haven't been seeing a lot of research focusing on the interactions between the ships and the port. And that's where the real complexity lies. And going forward, really hope to see more research and projects around those areas where you can see the ships of the future, how they can interact with the port of the future to make it a reality. And for that, Singapore, as all of you are aware, we're developing the next generation mega port at the Tuas. It has a 20 years development time frame from 2020 to 2040 in 4 phases. So it's a big window of opportunities for technology developers, researchers to come on board and try out new concepts of operations, and basically how the future ships is going to interact with the port before it arrives, and when it arrives, how it's going to talk to the next generation vessel traffic management system. Is it through human or through systems? What is the communication protocol like? How is it going to take out services relating to pilotage, tug? Does it still need some of these services, or you can do this remotely? How is it going to take supplies for the crew if there are still crew on the ship? How is it going to take in future energy systems? How is it going to carry out inspection? The port is going to carry out such an inspection. And all of these, there are a lot of concept operations possible. We like to explore them one by one, and of course we encourage companies and researchers to look into future concepts of operations in those areas. And for Singapore, we put a lot of focus on the more in terms of harbour crafts because that is more within our regulatory controls, and we can give exemptions and create regulatory sandbox to allow a lot of this experimentation to happen. And therefore, today, a lot of these Mars-related projects are actually relating to hovercraft. And we believe that these hovercraft projects will give us very useful data and learning and experience in terms of the challenges and the new concept operations that is possible. So to take one step forward, we also set up Living Lab together with our partner port operators, PSA and Jurong Port, to try out different concept operation. On the MPA end, basically what we set up is, I would say, on 3 fronts. One is the regulatory sandbox. Basically, this is a set of guidelines to guide companies towards testing of smart and autonomous ships. We also set up a digital and physical infrastructure. We don't have the luxury of the space in the port waters to allow a dedicated area, so-called, for autonomous ship testing. But we do sort of demarcate some of the areas at certain time that certain testing could actually take place progressively. So that's on the physical front. And on the digital front, we have been trying out different communication technology with different providers, and also set up the data hub to allow some of the historical data and as well as existing data in terms of the ship location, their navigation, speed, cost, because at any one point in time, there are like 1,000 vessels in the port water. So these all provide a lot of very rich information and scenarios for companies to actually, whether they want to do modeling simulations, they can actually use some of these data to try out their algorithms. So in terms of the how we look at it, not just Mars, but smart ship value chain, there are many stages of development, and definitely lots of opportunities for researchers and tech developers to look into. And the very important first steps is definitely the use case identification, because that defines everything. You need to choose the right use case where it brings value to the users, to the stakeholders involved. Not just doing autonomy for autonomy's sake, but it must really bring benefits. And I think many of us agree that today the conversation is not so much about removing the manning from the ship, but a lot focusing on enhancing the safety of the ship and the crew, enhancing the sustainability and emission reduction, and also in terms of productivity and cost reduction. More from those angles when we look at the subject of autonomous shipping. And once the use case has been identified, then it comes with also what is the future new concept operation is going to be like when the ship come into the port in terms of taking services and doing all the regulatory reporting. I think today a lot of the load is on the masters, the crew, and the shipping agents to do a lot of reporting, a lot of coordination of activities, a lot of communication amongst the different parties. So to bring value to these people who are facing challenges and problems, we believe autonomous shipping must not only look at autonomous navigation technology alone, but also to look at a lot of other aspects in terms of communication, in terms of handshaking with the shoreside operation, the coordination between masters and the port, and many other aspects. Of course, in terms of the projects, once it's been developed, then there will be a certification and deployment process. And in Singapore, basically, we take a progressive approach, which is that once the modeling and simulations has been done, tested successfully, then we will progressively move to a sea trial scenario where it starts with no ship in encountering to some ships in the encounter and more complex situation. So at least this gives us a risk managed approach of progressive sea trials. And finally, after deployment, of course, there will be operations supports and after sales services to support the smart ship operations. And these are all the so-called business and technology development opportunities. I would just say that this is not an exhaustive list of services that are possible. Let me move on to the progress of the projects in Singapore. Just now I talked about that actually a lot of our projects is focusing on hovercraft, mainly in these two classes of vessels, which is the tugboat and the flotsam vessels. These are basically small crafts that collect rubbish and garbage floating on the waters. And for clear reasons, because it provides a good value proposition. Today, I think the crew on the tugboat, besides operations, they also spend a lot of time in the waters navigating from point to point. So the projects, most of these projects involve autonomous navigation with collision detection and avoidance from navigating from point A to point B. And some of these projects has actually successfully completed. Of course, some of the technology they have incorporated include AI, sensor fusion, all those stuff. What is probably not in place yet is in terms of wider scale deployment, because there is today I think the cost of the deployment is still quite high, while the concept operations is proven to work in terms of collision detection and avoidance, but the cost of deployment is at the stage that the operators still need to overcome this issue, and hence there's a need for value engineering to reduce the cost of the autonomous technology. In terms of the things that we put in place, I have color code them. So basically, those green colors are the ones that the developments in Singapore, more or less, we have already done it. We have achieved some progress in those areas. Those in black, I can say still a lot of work in progress. And those in red, actually, we have not reached those stage yet. And it's not just only about the development in Singapore, because ultimately when companies do technology developments, operator deploy new technology, they also need to know that whatever that they have invested in is not only for one single port. And therefore, we also set out to align and harmonize a lot of this discussion with like-minded ports around the world who are willing to be involved in this mass discussion. We set up a mass port network with various ports around the world to basically look at the development of the detailed guidelines and conditions for mass trials and testing in the port, to establish common terminologies and communication standards for ship reporting and data exchange. Basically, it's to allow interoperability when one vessel needs to call at not only Port of Singapore, but other ports. And also, we want to also facilitate a possibility where if any companies in future want to do a port-to-port call between two ports to test out their mass vessel, these are the ports that will be more ready to facilitate such a sea trial. And this is my second last slide. So basically, I think some of you are aware, Singapore and Norway actually runs every 2 or 3 years, we run a joint R&D grant call to incentivize research community from both sides to do joint projects. And I mean, from our end, we also set up centers of excellence in the various areas in the next generation port, as what Prof. Chu has shared. In the area of autonomous shipping, we have set up a center of excellence for autonomous and remote operations under TCOMS at NUS, which also jointly published a roadmap with the Sintef, as you has earlier mentioned. The Center of Excellence in Maritime Energy and Sustainable Development at NTNU to look at future marine fuel, not only ocean-going vessels, but also for hovercraft. So they did a lot of studies and published a lot of reports, often also in collaboration with the industry, and also carry out some of the sea trials in terms of measuring some of these emissions of future fuel. And lastly, also focusing on maritime safety at Singapore Polytechnic. This is focusing more on crew training, which is also a very important aspect of the mass development. So our next joint grant call with the Research Council of Norway, MPA, SMI, RCN, we are planning for the next call, and definitely look forward to the collaboration between the research community from both ends. But very importantly, we also want to involve the industries from both ends to articulate the kind of challenges that the research community can work on together. So in summary, I will just summarize them that the next generation port development in Singapore is actually a very good opportunity for technology developers and research community to develop and test new concept operations, especially the interface between port and the ship, as well as the future energy solution. We have set up a living lab and regulatory sandbox to allow experimentation to take place without imposing penalty. And experimentation is important, and we expect this project to generate learning lessons for all the stakeholders involved. Third is that I think it's also very important that the selection of the projects under the MAS is important to demonstrate a clear value proposition to the end users, that it's not only about reduction of jobs, but more importantly, enhancing safety, sustainability, and productivity, and possibly cost reduction. And the choice of use case then becomes very critical. Fourth is that we also set up mechanisms and collaboration framework with our international port partners to make sure that whatever is tested in the Port of Singapore eventually should be interoperable with as many of the ports around the world as possible. And this will allow us to lower the cost of the adoption, because it's not just a technology customized for a specific port, but it's a technology that's interoperable across many different ports. And lastly, I think Singapore and Norway has set up a lot of centers, has a lot of research centers of excellence. And we strongly encourage both ends to explore how we can set up workshops together involving the industries to discuss what are the upcoming features that we like the research community to work on, tapping on the funding that RCN and MPA, SMI together will put in. So that is my last slide.
Thank you very much, Thomas. That was really, really informative, and it's a nice segue, because you mentioned about what are the needs of industry in terms of this whole area of autonomy and autonomous vessels. And we have Pia Meling from she's the VP of Massterly. And Massterly, if you're not aware, is a joint venture between Kongsberg Maritime and Wilhelmsen. And their purpose is to move towards zero-emission autonomous vessels. So they're right up there and thick into the development of this whole space. And we welcome Pia to share the progress and her thoughts. Over to you, Pia.
Thank you. So I'm very honored to represent the business side in this discussion, which of course is also an important factor. And just want to thank you for inviting me. We have a lot of good cooperation with in many research projects with, for example, Sintef, that we appreciate in terms of moving forward in this market. So as you mentioned, Kongsberg Maritime and Wilhelmsen are the two owners of Massterly, and this company has only been in operation for around 2 years. It was started in 2018. And these two companies are quite well known in Norway and also internationally for being large players and with a long history. But they're also quite innovative, and they spend a lot of money on testing out new technology and new business models. So you may know that Kongsberg Maritime has been leading in typically dynamic positioning technology and automation for many years. And they have, since they purchased Rolls-Royce Commercial Marine, they are now like a total integrator, system integrator for around 30,000 ships. And they also deliver to defense and aerospace. So they are trusted on cybersecurity and digital development. And Wilhelmsen Group has some, they're mostly known for owning and operating car carriers through Wallenius Wilhelmsen, but is more importantly a service provider for the global shipping industry through ships agency, ship management, and marine products deliveries. And we also in Wilhelmsen own quite a lot of terminals in and around the North Sea through North Sea Group. So a good mix there of technology and operational experience in this joint venture. And Massterly has set as a main target to deliver this shift in transportation from road to sea that a lot of cities and countries talk about in an environmentally friendly, safe and efficient way. Because there's still mostly talk about this shift, big cities really feel the pressure of traffic jams and pollution due to trucks, but it's very prohibitive cost level because the trucks are super cheap. So in Norway, we pay around $70 per hour for a truck, all inclusive. So this means that like a small container vessel can only compete on longer distance or large volumes today. And this is where autonomy technology comes into play, because if we can reduce the crew costs or even run unmanned vessels, the operating cost of those vessels will be lower, and we can basically compete with trucks on a shorter distance and smaller volume, which is our aim. Not to compete necessarily with existing vessels, but to steal market share from trucks and create new jobs in the maritime sector. But of course, a truck is very flexible. It takes the goods from A to B, while if we introduce a sea voyage instead for part of this journey, then we have the loading and unloading in addition, which is definitely a complicating factor. So, of course, having efficient solutions in port is paramount to succeed with this. Doesn't mean it has to be autonomous, but some degree of automation and efficiency in this whole logistics chain is important to actually be competitive with trucks. So Massterly has been set up to deliver basically everything a cargo owner needs in order to start using vessels instead of trucks or as an addition to trucks. Meaning that through our partners, our owners and other third-party partners, we're able to offer the full picture. Not only the autonomy and vessel, but also operation, logistics, insurance, potential financing, etc. Most of this is in-house in Wilhelmsen or Kongsberg systems, but some of it we will cooperate with other partners for. And as was mentioned earlier today by some of the other speakers, of course, autonomy is not a purpose in itself. It's just a means to get to some targets. And you could imagine that in the future, at least an unmanned vessel could be built with a lower capex as well, because if you remove everything on board that is related to people, not only the bridge, of course, but heating and ventilation systems, water, safety and salvage systems, etc., then you can actually design the vessel in a totally different way. Of course, the extra cost for the autonomy technology, the sensors, etc., is still quite prohibitive, but down the line, we expect that this can be evened out and you might be able to build cheaper vessels. But of course, most importantly, there will be a lower OPEX because one set of crew members could support several vessels from shore. That's the idea. And we see that it's also an enabler to afford investments in zero emission vessels, because that's more expensive as well. Both battery propulsion and of course hydrogen and new fuels like that will cost more. So it could be a way to afford that. And especially battery-driven vessels, 100% battery-driven vessels are easier to run in an unmanned state because you don't have a lot of engine room maintenance during the sea voyage. And then one can discuss the safety aspect, has been mentioned before as well. There's quite a lot of accidents today that are due to human error of some kind, and at least those might be reduced, while of course we are introducing new risks as well. We have to be aware of that. But we believe this could definitely improve safety and efficiency as well. But it's a gradual journey towards the unmanned bridge or unmanned ship, which is level 4 on this graph to the left there. So of course a lot of processes are already automatic on board ships, and I'll give you an example of that. But our purpose is to move towards unmanned approvals for unmanned vessels for Massterly. And then, as mentioned, these are the 5 levels that the Norwegian Maritime Authority have defined. There are different levels defined by different maritime authorities and different class societies, but I think we will agree in the end on some sort of division. But it's level 4 we're looking at, and we are cooperating with not only the authorities and the individual GLS class, but also the University of Southeastern Norway, specifically on what competencies are needed in the Shore Control Center or Remote Operations Center. So actually they are now starting a curriculum. We will test it with a few people now already in November on a specific training program for Shore Control Center operators. So we're getting into more practical details. But of course we have to prove, that's the guiding principle, as you probably are aware, that the autonomous functions are equally safe or safer than conventional operations, and we need to prove that within all the existing framework internationally and nationally. So it's quite a big undertaking. But we are definitely getting there in Norway now, as we have concrete projects that need permission. But most of the regulatory framework that we have is very much based on roles today, who does what, and we need to move towards understanding the objective of the regulation and solve this through the actions that we select. So that's just that's just my 10 cents on that one. And this is Bastøfosen. It's a RoPax ferry that is going between 2 ports in southern Norway, crossing the Oslo Fjord. And they have 36,000 dockings per year at the same port. They are using auto-docking functionality from Kongsberg. They still have a full bridge. There's no reduced manning at all, but they just automated the docking process. Because it is a repetitive process that actually can be optimized better by a machine than say 10 different captains working shifts, because they do it all their way. And the crew are quite happy, and the bridge crew are quite happy with this. They're using it now. In most of the cases, they use the auto-docking because it's saving fuel, it's saving time. It's much more predictable exactly when the ferry will be docked and ready to take on passengers. And they're basically saving up to 1 hour per day in docking time that they could use to charge once this vessel is becoming fully electric. So this is an example of a different business case. It's not about reducing crew at all. It's about having a really efficient turnaround in port, reducing both the cost of fuel and of course the CO2 footprint, and adding time for charging. You have probably all heard about this vessel. It was the world's first unmanned container vessel, zero emission. It was launched by Yara, the fertilizer producer. And it's quite an ambitious project. It has been a little bit delayed because of COVID, but it's now going ahead. And this is an example of another task that has been automated on board this vessel. It's MacGregor has delivered a robotic arm that will do the mooring instead of people doing it. So this is probably a one-of-a-kind solution at the moment. There's of course existing already different mooring solutions that require port infrastructure like vacuum or magnet mooring, but this would work in any port. That's the idea. The vessel is now in the Vard yard in Norway, in Ålesund, where she's undergoing sea trials. So very soon she will be ready for the first tests, but it will still be a while until Yara can put her into operation, because they need to finalize their port side investments and changes as well. But the vessel is soon ready for testing. And now this one is another cargo owner called ASKO. It's a large grocery distributor in Norway. They have around 800 trucks on the road every day. But now they are, instead of driving the trucks all around the Oslo fjord, they're going to cross here with these 2 unmanned and 100% battery-driven vessels. So these vessels can take 16 trailers each, as you see, and it will be unmanned in the end, and they will be picked up on the other side by a driver and taken to the final destination. This is quite interesting because ASKO is just a cargo owner. They have no maritime experience at all. And now they have started a company called ASKO Maritime, and they have signed contracts for 2 of these vessels that are currently constructed in India at the Cochin shipyard. And they are becoming ship owners. This is an example of what was mentioned earlier by Øyvind. I think that this is changing the game a little bit. Instead of them waiting for ship owners to come with the solution that they're looking for, they're now taking full control and they're owning these vessels. They will be replacing 150 trucks daily on a certain distance and actually reduce the CO2 emissions by 5,000 tons per year. And this is the main reason for ASKO. They want to have a zero emission logistics chain. They're very, very concerned about their CO2 footprint, and they have ambitious targets for that. But they also see that they can get a much more efficient logistics chain. And they are, in the future, they will probably use hydrogen trucks as well. And they see that there will be restrictions through a tunnel that they're using to go through Oslo today, that those trucks may not be allowed in that tunnel. And then this is a much more safe and efficient logistics chain for them. So as you see, the vessels will be delivered the end of the year 2021 or early 2022. And we said that let's have a manned operation, reduced manned operation with 2 people on board for around 2 years. And then we hope that we could have a ready approval and tested and safe unmanned operation from 2024. Of course, this is not set in stone. It depends a lot on the regulations and how everything works, but this is at least the timeline as it looks now. Yeah, I forgot to say that also in terms of new business models, back to ASKO, that Massterly is now, delivering basically everything to this customer. So first, we were replacing a traditional ship broker, a S&P broker. They did not use a broker to find the yard. They used Massterly, and we don't charge 1 or 2% of the cost as a normal broker does. So we only did it on a cost basis. So that was a lot cheaper for them to use Massterly than a traditional broker to find the yard and negotiate with the yards. And now we're doing site management and new building management and project management for ASKO. And we have to do a lot of remote supervision because of COVID. So that's also going to be interesting. It's a new way of doing that. But this is an example of disruption, basically, that we can offer roles that were not there before in this setup. This is a test with switcher tugs, and I know that Singapore has similar testing on remote control tugs. This is not autonomous, it's a remote one person remote controlling one tug, but it's still very interesting business case because these tugs spend most of their time just waiting. So having people on board sitting there just waiting doesn't really make sense for anybody. So looking at doing that remotely makes sense commercially as well. And of course, there are already a lot of autonomous unmanned, both underwater vehicles and surface vehicles out there of smaller kinds, used for search and rescue, mapping the seabed, doing different surveys. And this top left one is Kongsberg's Sounder. This is also commercially used to find fish. So that's another use case of autonomy. And we have in Norway also the defense, the research, Norwegian Research for Defense. They're looking at autonomous minesweepers, which definitely makes sense, because why do you want to put people into a risky situation like this? We could look at remote controlled firefighting vessels for ports. Definitely makes sense as well. A lot of waiting time as the tugs, and of course a dangerous environment to be in once you are there to put out the fire. Why put people close to these flames and toxic gas? And then the last use case, which is also quite interesting, where we see a lot of traction many places, is this kind of smart city ferry concept, where instead of building bridges, tunnels, or more roads in the highly populated areas, using the surrounding seaways, and creating like a fleet of smaller ferries that can be there on demand, zero emission, and maybe not unmanned, but perhaps manned with service personnel instead of a certified captain or navigator. But we still, as soon as we talk about adding passengers, there's a higher, there's less risk willingness, of course. So we still have a while, I think, until this is going to be unmanned at least, and that might not also be the purpose. The purpose might be to have better service, basically, than what ferries are today. So we are, for most of these, or for basically all of these applications that are commercial, we need to have people in the loop still, not only because of safety, but also because of the regulations that somebody needs to be responsible. And that's why we're building remote operation centers, which can, of course, support the operations, assist the crew, take direct control, like with the tugs, or move into autonomous operations, which is what we call level 4 in Norway, where the idea is not, of course, to do a one-to-one remote control, but monitor and be able to intervene in case. But it's important that if the remote operations center does not intervene because they cannot, they lost communication, something happened, the vessels should still be in a safe state and not pose any threat to the surroundings. So that's our principle at all times, that we should not be dependent still of the remote operations center to interact with the vessel in terms of safety. Then it should have a fail-safe mode that it goes into. In Kongsberg facilities, they started testing this already a couple of years ago, and this is the King of Norway. He was there to visit, very interested in technology. Now we have set up a desk, just a simple desk inside our office in Massterly, outside Oslo, where we are testing out what would be the best user interface. So this is the first setup of that, where you kind of have the bridge view here. You have more of a bird's eye view on the top right corner. We have the C-scope, what the kind of the VTS will see on the left top corner. And you would have a list of your vessels and their schedule here. And you would have on the right side a health status on all the equipment on board. And radar, ECDIS, and conning are mandatory views that you need to add as well. But we don't know yet how this will be as a working environment, and we need to test that. Of course, we're doing that in research projects with various partners, but I guess the real testing will be when this ASCO or Yara vessel will be in operation and still people on board, but we will have somebody in this remote operation center monitoring and testing how it would be to have the responsibility. And this is my last slide as well. Also, as been mentioned by several of the speakers, that we need to focus on more than just the vessel and the sea transport. It's the whole interplay with all the stakeholders, and especially the whole logistics chain. If we're talking about goods, we need to make the whole all of this information somehow available and optimized. And I think the remote operations center could have a good role to play in optimizing more than just the vessel transportation. So we need to collaborate with the ports and with shore transportation to make sure that this. And of course, we are looking forward to cooperating with Singapore, who are very advanced in this field, and we hope that we could get some good projects running together. Thanks.
Thank you very much, Pierre. And I love the room. I remember visiting it last year at North Shipping, and we went to the room. You have more screens than what we saw the first time. So
yeah,
more than a year ago.
We of course don't know if more is better.
Yeah, this is true, but it looks a lot more impressive for sure, and it's nice to see the Birkeland project moving well, because I know the Polish yard had some problems as well. So, but it's nice to see it on water, and we're looking forward to more great results from there. Thank you very much for that. Next up, we have Prof. Mary-Ann Lundteigen. She's from NTNU, and she is actually the director of the SFI Auto Ship Research Center, and also the co-director of SFI SubPro. Prof. Mary, we are welcome. Well, welcome to the group, and I hope you had a good meeting before this. Thank you so much for your time, and we're looking forward to your presentation. Over to you, Mary.
Yes, thank you. You can both see my screen and hear me well?
Yes, we can. Yes.
Yeah, thank you. So thank you for getting this opportunity to present the SFI Autoship on this event. This is actually a new initiative among, as you already heard, numerous ongoing initiatives in the area of autonomous ships. So I will try to go through some of the activities that we plan. This is a new center starting up in the end of this year. So we have not yet started. So this is really an overview of our ambitions and plans. But I would like to start by explaining what is an SFI, since we have this 3-letter abbreviation in front of the term autoship. Some of you may be familiar with it, but not all of you. So first, the SFI stands for Research-Based Innovation Center, and this is a Norwegian kind of construction where you can get a larger horizon. It's 8 years, and the Norwegian Research Council will contribute with a quite significant amount, up to 12 million per year. And you see the currency translation there, given that you have also industry funding. So such a center requires funding from industry, not only cash, but actually also active participation through in-kind contribution. And as I mentioned, what is a bit special with an SFI compared to maybe another project is the duration, which is 8 years. So it has a long horizon, giving opportunities to really focus and over a significant amount of time. The focus shall be on technology and knowledge transfer, internationalization, researcher training to enhance the competitiveness of Norwegian industry. But of course, being competitive is also relies on the ability to collaborate internationally. In Norway, there are several of these centers in many different domains, and typically 15 to 20 of these are started every 4 to 5 years. So currently there are more than 20 ongoing centers in many different areas in Norway. And the SFI has very demanding success criteria from the Research Council on which we are measured. And they include, of course, our ability to establish international collaboration. So I just attached the link, which is also available in English. So you can, if you're interested, read more about what an SFI is. I guess it's maybe not necessary to repeat why we, as many others, put focus on autonomous ships. I could hear from the previous presentations that this has already been summarized, but I've just made a very simple illustration, which I hope will kind of take out the main issues. First of all, and where also Pia Meling gave many examples, autonomous ships is not a means by itself, but together with other efforts, it gives an opportunity for new ship designs and new ways of operation. And even, as was mentioned, that companies also can take new roles. This doesn't only rely on autonomy on board, and as already elaborated earlier, autonomy doesn't necessarily mean full autonomy, but up to a certain degree at least. It also relies on the autonomy in harbor, how that is carried out. And we also saw some examples of that in the previous presentation. Maybe one additional very important enabler, which is not really related to autonomy, is the transfer to zero emission energy systems, which can make also smaller ships more economic and environmental friendly, and also therefore a better business case. That hasn't to do with an autonomy, but together with autonomy, that is an important enabler. And also mentioned earlier today, the ship itself doesn't create these new opportunities alone, but it's the whole infrastructure covering the vessel, the harbor, the other related infrastructures that give the good business cases. Of course, when this is in place, there are opportunities indicated already with reduced costs, more flexible and scalable transportation, not only of goods, but we saw on the last slide of, or one of the last slides of Pia Meling, also the possibility of more flexible and scalable transportation of people. When it comes to safety, a very important issue is that when you raise autonomy of ships and systems, you require not or you expect more of the safety. You will require at least as safe as or better safety level. And with autonomy, there can be new risks, but also better ways of monitoring what's ongoing. So that is also an opportunity to improve safety, and because you will have a better tracking of the environment and be able to have better decision support, and also the reduced emissions. So this was of course a starting point also for this research center. So then I would like to turn the attention to the SFE Autoship as such. Autoship stands for autonomous ships. We have the short title for safe and sustainable operations. The objective is to develop and manage technology systems and operations for safe, sustainable, secure and cost-effective autonomous sea transport and operations. And why? Norway has already a strong position with internationally leading manufacturers, research institutes, academic groups, and class companies. And of course, our coast, waterways, and also the needs for international transportation give many relevant business case opportunities, if we can make them cost effective and demonstrate safety, both for ship owners and operators. And we also already have some infrastructures for testing also at sea, which are rather attractive. When it comes to the SFI Autoship, we are now in the, since we haven't started up and not finalized all the contractual work, screenshot there. Wait, sorry. I will just go back to the presentation. I tried to remove the picture that come across the screen. We have more than 20 partners with us. We have 4 research partners: NTNU, the Norwegian University of Science and Technology, Sintef, University of Oslo, and also the Institute for Energy Research, IFE. From the industry partners, we have 12 covering segments from manufacturers to ship operators. Some of them are probably joining here today. And we also have some public and governmental partners. We have the Trondheim Havn, which is those that operates the ports in Trondheim City. We have the Trondheim Municipal, and we have the Norwegian Coastal Administration, and also the Norwegian Maritime Authority. The center is hosted by the Department of Engineering Cybernetics at NTNU. It is multidisciplinary, as you will see when I will shortly present the work packages that we have defined. And the budget over the 8 years is around 240 million Norwegian crowns, which should be approximately 24 million euros over this period. And the SFI will, in addition to the innovation results, educate around 20 PhDs, 5 postdocs, and estimate of 150 master students. So an SFI is also educating the competence that the industry needs. And the center director is myself, Marianne Lundteigen. The startup, as I mentioned, December 2020. So then I would like to turn the attention to our scope and way of working. First of all, we have there are 7 work packages that I will shortly introduce, but I will start with one of them, which is on use cases. That is a very key way of working in this SFI, that we direct the research, which are more long-term, to well-defined business cases. And the business cases are typically owned, meaning kind of led by one of the industry partners. We have so far defined one in deep sea bulk shipping, one in short sea container shipping, where it was mentioned earlier, like ASKO and Yara Birkeland as examples. We have the urban person ferries, or also called smart ferries. And we also have a use case which is more focusing on, I would say, special surface autonomous operations. In this case, we are looking into an autonomous vessel that is following an underwater vessel that do pipeline inspections. So these use cases can also change during the 8-year period. Around these use cases, we will focus on different aspects, starting with the auto remote. I will go into the details. I will just give them by name now and come back more on the explanation. We have one on digital infrastructure. We have one work package on a remote operations center and human factors. We have one work package on safety and assurance, and one work package on sustainable operations. And finally, a work package focusing on the innovation processes and the commercialization. The SFI relies on a close collaboration, as I mentioned, so I would just like to re-emphasize that. So this is not work packages that are carried out alone by the research partners, but it relies on involvement from the industry partners and the public partners through participation with in-kind activities. Then I would like to shortly say something about each of the work packages. Some of you might have some more in-depth background in some of these areas. I will start with the auto remote. That work package will focus on developing perception and decision-making systems that will enable these autonomous surface ships to accomplish their mission, and with emphasis also to handle the extraordinary events. Of course, that requires attention to several topics, situation awareness and the use of sensor fusion to enhance autonomous decision-making. It relies on this simultaneously localization and map building called SLAM and extended object tracking. Given that information, the idea is to work on the integration of these into the automatic control systems and also combining different control strategies from optimal control, artificial intelligence frameworks and low-level control algorithms together so that they develop both reliable and resilient autonomous decision making. Because as this illustration to the right shows, for some of these business cases, the autonomous ships will operate in environments where you have also other activities, many of those not being manned or trained. So this is a very critical activity, both to be able to do the navigation, but also demonstrate the safety. Then we have a work package on the digital infrastructure. And the purpose there is to develop reliable and secure data transfer among the ship, the remote operation center, and other marine traffics. Here we have a focus on various aspects of that. First of all, the communication between these actors that I already mentioned. We will focus on radio and radar technology to be cooperative, massive, multiple input, multiple output, and sensors fusion strategies. We will look at protocols and prototypes, focus on making digital collision regulation rules, and also on the cybersecurity. That will be also a very important aspect of communication, since autonomy relies heavily on the availability of digital communication that is not compromised. The cybersecurity cannot be overlooked. We have a work package on the remote operation center and human factors. I think this overlaps probably a bit also with what Pia Meling from Massterly also pinpointed in some of the ongoing activities that they are involved in. It is also an aspect we will look into in this center to develop safe and efficient human-machine interfaces and interaction for remote operation centers. And here we will focus on both the definition of how we can utilize all the necessary data on sensor fusion to give sufficient information to make a reliable basis for decision support. We will also focus on the use, we have called it usable human-centered design, meaning developing more insight to how you can construct these centers to facilitate different requirements to situation awareness, workload, and communication with also conventional ships that cannot be overlooked. Also procedure manning and competence that is closely to the above points mentioned. And of course, depending on the level of autonomy, I think it was mentioned in the earlier presentation that we need to move to a more function-based direction on the way we define roles, because some of the traditional responsibilities and who have had the responsibility for the different tasks will of course change with this new way of operation. And it may also be a need to handle different kind of categories depending on the level of autonomy in each case. Then we have the work package on safety and assurance, just to restate a very important aspect when it comes to introducing technology to replace humans. We expect a bit more of the technology than we sometimes do by humans. So ensuring safety is a very critical activity. And in this center, we will focus on research and development of novel methods, models, and tools for risk management, and safe design and operation of autonomous ships. And here we have the focus on risk management in operation, the need to decide on what type of information will you require in real time, how to aggregate and put this information together to make decision support around the risk level, and also support in how to act and also select good mitigating measures. These must be more real-time situation. Then we will have a focus on how we can ensure that we build the safety into design, that we think about what will be the reliance on the technology, what will be the reliance on other systems. This is of course something that all manufacturers are focusing on, but we will try to develop some good principles for how this is being done within the frameworks that exist today. For example, we will look into the application of digital twins more actively when we do the demonstration of safety during the design phase. We will look at system verification and simulation, also focusing on cost-efficient approaches, since these scenarios that can arise when you look at the picture to the right here, you can envision many scenarios that can occur, and of course, how do you do the system verification and simulation? How do you identify the key scenarios to choose? And because it would be endless of situations that could be foreseen, so this is something that needs to be thought through. We also will have an activity, and here we have the collaboration with the University in Oslo, which are experts on the maritime law as the last bullet point. It's a very important aspect, when it comes to changing the responsibilities of for example, in relation to the collision avoidance regulation. It is necessary to also look into the liability with respect to the laws, and this is also an important issue for insurance companies that will try to understand also better who will be responsible when it comes to understanding the risk related to the autonomous operation. The work package on sustainable operation will be the work package where we will focus not only on the ship, but also on the ship as part of a value chain. So here the research objective is to develop the next generation cost-effective and environmental friendly sea transport system, with focus on the shipping part of a larger system. So here the research will focus on developing better models and systems to do the cost-benefit analysis for selecting the most optimum business cases with key performance indicators. It will be a focus on green ship operations, how to optimize the solutions considering the different technologies available, both in the case of unmanned and periodically unmanned ships. And what is ongoing in the harbor, it was also mentioned in the previous presentation, looking into some specific technologies and then the methods to raise the level of automation at the ship port interaction. Last, I will come back to the use cases, which has a very key, and I placed them in the heart of the SFI when I presented the overview earlier. Objective of this task is to demonstrate the applicability and value-adding potential of research and innovation results from the center, and also disclose new problems for further research, because the SFI should also identify new issues to be looked into. So we are now in the process of maturing the use cases. This is an activity we do now, and we will also redo during the center period. We will also focus here on the integration of research results into design and operational concepts, and this is where the partners can link their own activities closely and see how can the results be adapted or applied in my own organization and services. And then demonstrations through simulation, model scale, and or full-scale demonstrators. That will be, of course, a bit different for the different use cases. So this was actually my planned overview of the SFI Autoship. We have a homepage. I added the link here. It's a bit still under construction, but I hope at least this gave you some overview of what our plans are for the next 8 years.
Thank you for that, Prof. Mary. That's really exciting times ahead, especially in the research and development in this whole area, which is really complex, and it's left to the imagination, really, and how much we want to really push the boundaries on fully autonomous vessels. So, and I'm actually now thinking of how Singapore and SFI and Sintef all can start cracking our heads and see how we can work together in the future. I think there's a lot of opportunities to collaborate. We're just about to enter into our panel discussion. So maybe if all the speakers could put on your video so we can see your beautiful faces. I'll hand over to Dr. Øyvind.
Yep, Marianne, I think first of all you should stop sharing your screen, because now we have a duplicate of all our faces. I really enjoyed these different presentations. Fully agree with Sanjay. It's impressive to see how things are moving forward on different paths, but having the same vision and really driving towards these bigger transformation of the whole maritime system as we know it today. I would like to pick up on one comment that I noted from Thomas' presentation. I see you've raised your hand also, so you'll be given the opportunity to answer them. But while Thomas is okay, now the hand is down. What I picked up was then the interaction between ship and port, specifically looking at these mega port operations, because what I see from Marianne's presentation is one use case on ship-port interaction, but then let's say on a Norwegian scale, smaller port, and from Pia, also a focus on autonomy with respect to small port docking, etc., etc. How do we address Thomas' question on this ship-port interaction at a larger scale? Because that's where I see the key interaction between Norway and Singapore, how we can come together and really form new projects that each of us separately couldn't do. Marianne, could you start, and then I can give the word to Pia afterwards. What's your thoughts on this?
Okay, Yeah, I see that, you know, from the Norwegian side, as you mentioned, if we look at, you know, I pointed out in one of the first slides that one of the opportunities that maybe here in Norway, at least with our coast, is the possibility to have more flexibility and utilize some of the existing or upgrade the existing infrastructure for more autonomous transport. So I agree that the larger scale seems to be an interesting opportunity. Maybe not. So some solutions would be overlapping. I mean, they would more or less have the same requirements if you go down to the tiny details, but to identify more clearly what are really the effect of the upscaling on the requirements and on the systems. That could have been an interesting exercise to really understand both downscaling and upscaling.
Pia, onwards to you, please.
Yeah, it's a major challenge for us to make micro ports work in an efficient and cost-efficient way, especially in Norway, if we're really going to bring in new business. But I think for cooperation with the Port of Singapore, you know, the Kongsberg Nordcontrol already are delivering the VTS system for Port of Singapore, and I know there's living lab environment there. So for us to work more closely on especially the interaction between the VTS and the autonomous ships could be a very interesting case. I was going to go to Singapore this year, but Corona kind of stopped that. But we definitely would like to cooperate much more with the Port of Singapore. And another case, I heard that you're also moving parts of your container port out of the city center, and it's the same thing that Port of Bergen is looking at now. And it's a very small port compared to Singapore, but I think this is a trend also that ports are, you know, overcrowded and there's no more land basically around the big cities, and they want to use that land for commercial and property development. So the case of moving ports further away from the city and further away from the users of the cargo, you might say, and then adding autonomous vessels in this kind of intra-port movement, I think is also a very interesting case that we will work with the Port of Bergen on this. And I would love to work with the Port of Singapore, of course, also on this in a much larger scale, because otherwise it would just be more land transport from the kind of outer port into the users. So that's an area where we definitely could be looking at making a concept that works for both smaller ports and larger ports in many areas.
But then, thank you. But then to Thomas, because I noticed that both Marianne and Pia in their presentations started with use cases. And then we're drilling down from real use cases down to the research questions and the developments that had to be done. And I guess also on your part, you have been developing, I mean, the number of use cases you could probably develop in a major port like Singapore would be enormous. But I guess that you have developed some key use cases that might possibly be shared with the developments that are being done also in Norway. Could you comment a bit on that, please, so we get a better picture of the way you have been progressing this part?
Yeah, so there are quite a few aspects. So maybe I cover on the ship-port interaction first. So my observation today is that the companies that are involved in the technology development and testing, they are going ahead with their own e-navigation developments, testing different stuff, not so much for smart ships, but more for the next phase of how the e-navigation, how the ship-port communication is going to be like. And in this area, actually, I would like to see how the companies that are involved in the testing and in the research can actually involve our research community so that whatever they are doing is kind of not disconnect from what the people who are working on the autonomy of the ship is doing. So I think plugging them into the developments of the next generation vessel traffic management, next generation communication system regarding VHF satellite systems, the ship-to-ship communication protocol of the future, ship-to-port communication protocol of the future. I think all these are important aspects that the industries and the research community can better plug in. We will try to see whether we can organize workshops where some of these companies can actually bring on the research partners from both Singapore and Norway. So that's one aspect. Second area is specific to the use cases that I talk about, tugboats, flotsams and all those stuff. Ferry, of course. As I mentioned, the cost, we have quite a number of pilots and all those stuff. Systems been deployed on the tugboats, navigation, all these, no problem. But it seems to me that the wider scale deployment of the technology hits a roadblock in terms of the cost of adoption. I don't know whether in terms of R&D, whether there's opportunity to lower the cost of some of these technology components, because if the cost is prohibitive, then adoption is going to continue to be a challenge. So cost reduction then becomes a very important aspect of the R&D.
Yeah, exactly. Then I noted during the presentations of Allan and Prof. Chu, you were giving very good presentations on the value and the development of digital twins from different perspectives, from the shipboard, ship physics, and with respect to Prof. Chu, I was really intrigued and happy to see the focus on developing framework for tools rather than specific tools to serve specific purposes. Because my experience is that if you develop a good framework, then it's easier to invite other people in to do their development. But on the other hand, many organizations like to develop their own framework. I like to come back to an anecdote from the Norwegian energy company Statoil, which is now Equinor. At the start of this wave of digital twins, they were approached by none less than 12 different commercial companies who tried to convince them then that their framework for a digital twin would solve all problems that Statoil was seeing. And what did Statoil do? Of course, took one step back and then waited until the industry had consolidated. So a move from everyone trying to promote their digital twin framework until you had consolidation. And I'm very happy to see that in Norway that's been happening with Kongsberg, NVGL, NTNU, Sintef moving together and joining on one framework. But the issue we're seeing is still this framework of framework. How can we make different frameworks move together? If you want to have your framework, Prof. Chu, adopted in France, in Denmark, in the US, how can you convince them that you are the genius, that they have to put their work aside and adopt your work instead? That's a hard sell. The other is then how can you make systems that make different frameworks communicate and work together? Have you given any thought to that, how you can generalize to the next level such that this genetic thinking would go across the world and have a lot of developers focus on the same way of conceptual thinking, on conceptual developments? Do you have comments on that? If you have comments on that, then please unmute.
Yeah, that's right. Sorry, I didn't realize that I have to mute my mic. Okay, I think it's a very good question that you have raised. And that's the reason why we understand that all around the world, people have come up with different kind of approach to develop this digital twin. And so they also have different kind of platform that is able to create this digital twin. And that is the reason why we realized that, and we wanted to actually come out with this PodML standard. So as I mentioned earlier in my earlier slide, right, this POT-ML standard, right, is a universal markup language that defines or specify the configuration of the port. And if you are able to push this standard, right, as international standard that is adopted by, let's say, ISO or let's say United Nations, then there will be a drive for many companies when they build this digital twin, right, will use this standard to define what a port is. And if we are able to do that, then at the end of the day, right, regardless of what framework you use, right, this POT-ML, right, can be used to actually port to many different digital twin framework. It's because it's neutral in that sense. You understand where I'm coming from? So actually, it's not a framework that actually we are trying to build, because we know that any other countries, they will have their own framework. Different companies will come out with their own types of submission platform. But what we are trying to say that, supposing if we are able to push this POT-ML standard to be used as a language to define the port configuration, and also eventually also in terms of the port processes as well, then at the end of the day, once when you are able to do that, right, then if a company are able to build a compiler, right, that is able to read this standard, then eventually it can just easily be converted to a digital twin. Okay.
Yeah, thank you. Because then there was one question coming in the chat now, but I would like to address slightly on the side perhaps, but I would like to pass on the question to Allan first, and then address the question of Fujitsu. Both of you, in the perspective of digital twins, and specific to Allan, the work that you were projecting on a digital twin for the Singapore Sea area, that to me is intriguing. That's lifting it to the next level, where you're looking at the holistic perspective, not the ship, not ship-to-ship communication, but a digital twin of the whole region. If we get there, then I think that would be a huge asset to effective port operation and effective maritime operation in the region. But how do you see this now, or are you at this stage integrating that with the vessel traffic management system of today? How are you integrating that with the present systems that are operational in Singapore? Do you have a clear pathway to that?
That's good question. Actually, so far it's a standalone model, but again, this is a rather large computational model. And I think it's not amenable to something like an XML structure. But the end goal is actually to get to a real-time model that then I think could interface. And it's actually been brought up, the issue of how to communicate this information with the vessels, which would obviously be key to getting the whole system to work together. So I think we're still in the early phases of this model development, but yeah, at some point we need to see how the structure can interface with the other systems that are out there already, because it doesn't make sense to have separate standalone systems if they're not interconnected and they're not communicating together. I had an interesting conversation with a fellow from Siemens one day, and he was telling me about their simulation tools and this framework that they have. So it's all about the interfaces, and they can string together different types of simulation tools, be it a simple formula or a very complex program, instrumentation, live data, and they have it so that all these things are actually interoperable, and you can plug and play things that he said he's surprised how well it works. Sometimes things that you think would not be compatible, they actually work fairly easily and give reasonable and practical results. So I'm encouraged that it's that type of framework where each module can be developed up to a point independently, and then it's about the interface with the other modules that could be standardized. And I think there's a good argument for doing that. I mean, I've worked on fairly complex monitoring systems for offshore platforms. It doesn't make sense to have one system for the plant, one system for the machinery, one system for the meadows. The owner wants the operator, one system.
Yeah. Yeah, you're dropping out, Allan, in the last, but I think what it also strikes me is that this is very similar to Prof. Chu's comments that you have the digital twins need to be functionally oriented. So it's not one digital twin for everything. But to me, this is kind of the same as I see in geographical information systems, where you have layers. You have layers with the different. Now I think my camera is stuck. You have layers with a different complexity, and you can move from one layer to the next layer and pick up more and more complexity as you go, or sort of move layer by layer in that way. So I think the concept is really intriguing to see how this is going to evolve in the near future. But then, Marianne, you had a question coming in the chat. You're commended for an excellent presentation, and then the question is on situational awareness as very important for autonomous ships and the mixed traffic environments for manned ships. The question is if you could elaborate more on the challenges you're going to target with respect to situational awareness.
Yeah. Even if I'm not too deep into all the work packages, my area is more in the work package 7 on safety and risk modeling. I could pinpoint some topics which I hope you also seem to recognize, and that is first of all what has been identified as a challenge is to have the situation awareness up to a level where it actually corresponds to the way the human would recognize. Currently there are certain limitations of the technology, so to pinpoint how we could raise it at an even higher level, that is one of the issues we are targeting. Also, some of the technologies for situation awareness is also prepared for use by humans, and of course for many autonomy levels the human will be part of the decision making. But if we are going to use the situational awareness information for autonomous decision making, we will require a bit more. So that is also an issue that is going to be looked into. And what I would mention as the last point is that there are many initiatives in this respect already, of course, and also on the Norwegian side to try to build on what has already been done. In Norway, we have had, for example, a project in focusing more on the small-scale ferries, and some of these issues have been topics there as well. Also, the non-GNSS self-localization is also a topic to be looked into. There you have experience from maybe other applications which you can build on to see how can we improve their adaptation to autonomy. So these are just some examples.
Thank you. Sanjay, you had a comment?
Yeah, thanks for that, Øyvind. I'm just trying to wrap my head around a couple of things on situational awareness. I mean, we have one which is at the vessel level and how the vessel reacts to wind, currents, and waves. And then you have another situational awareness which we are much closer to, which means if we go into a remote operation center, then the person operating remotely needs to have a certain level of situational awareness of the vessel that is physically not near him, and he doesn't feel the tug of the wave and things like that. And which also brings me to this whole research that you all are doing around human-centric factors, the human factors around the remote operations center. And I'm just trying to see how these things come together, because we have set up a center of excellence for maritime safety, and it just happens that Kongsberg just won the tender to build the advanced navigational research simulator. And I'm just trying to see whether there's an opportunity here that we can kind of leverage each other's investments and knowledge to create a research program around this human-centric issues around situation awareness in the remote centers, operating centers. Just your thoughts on that, both from Pierre and Marianne, and also maybe from Thomas as well.
Pia, could you go first, please?
Yeah, it's a very interesting area that we need more research in, and I think just remembering that the situational awareness that an autonomous system can deliver in terms of having excellent camera vision, for example, night vision, things like that can actually enhance the situational awareness for the remote operation operators. They will be able to objects further away, but of course the issue is about classification of objects autonomously. That's the big question, and I think those nations and players that have most data and pictures that they can run these algorithms on will succeed, and that's probably China at the moment. They have so much data from everything being filmed and surveyed, and I'm pretty sure they will benefit from that in terms of developing these algorithms to detect and understand what objects are. But of course, their focus is probably more on the land side and car industry still. But I think it's very interesting to see what does it. I mean, for the remote operations center operator to sit there and have excellent computer vision and alerts, etc., but not being on board. What does it mean? In what areas are you losing out on the human aspect there? And that's something that we haven't really done too much research on yet. And I think that's an area where we really should be testing various scenarios in a simulator, of course, and then be ready for the real thing.
Thomas, do you have any comments to that? And then we have one external afterwards. But Thomas, please.
Just reflecting on the situation, we're trying to do a project on remote pilotage. Basically trying to mimic the whole scenario that the pilots, instead of on board the vessel trying to navigate with the captains, now he's doing this thing remotely from the shore. And indeed, there are a lot of human factor considerations, because it's quite different. When you look at the 360 degree on the ship and on the shore, and how do you actually replicate this whole scenario to the shore side to have the same look and feel and touch, and maybe don't need smell, but it's quite different. So still a lot of challenges to overcome. That's one. How to replicate the whole scenario back to the shore so that you feel almost as if you are over there. At least for remote operation, I'm not talking about autonomous. A lot of challenges. So the confidence is not there. The remote pilot is just not today, still not at the competence level that they can take over that whole ship to navigate. That's a problem. Human factors definitely play a role, but there are other aspects as well. I think communication technology is still quite lacking. The latencies of the information that's feeding back to the shore for pilotage and tug operations, you need it quite real time. It's like within 1 or 2 seconds. You cannot have a delay of 5 seconds where you see the scenario 5 seconds later. It's not going to work. You're going to get a serious situation out there. So communication technology today in the port waters still remain a challenge. 4G, unfortunately, still not good enough for such a requirement, I would say. I'm just reflecting upon this aspect. Yeah.
And I think Batalden had a question from the side. Please go ahead.
Hi everyone, thank you for very nice presentations. I work at EIT, the Arctic University of Norway, talking about this situation awareness. And I understand, Sanjay, you are calling for some joint efforts to address this topic. we have done some studies on situation awareness in the maritime industry, even on ordinary ship bridges. And I think there's a long way to go, because we actually don't really manage to map situation awareness on an ordinary ship. And then how we can benchmark that and compare it with that command center, control center. So I agree with you, there's a need for quite a lot of research here to support the development on that command centers.
Just to, since you were breaking up a bit at the start, Bjørn Morten. So Bjørn Morten Datalden is from the Arctic University in Tromsø. So also having a good activity on ship operation and maritime activities. Then Pia, you have your hand raised. Please go ahead.
Yeah, I just had a comment to what Thomas said, that we don't necessarily need to replicate what's being done on board, because we want to do things better as well. It's not perfect what's done today either. So I mean, it's easy to fall into that idea that we just need to exactly what the humans are doing today, and I believe we need to look at improving that. And it doesn't mean that you need the same. You need to transfer the exact same experience. And about the confidence of the operators, of course, this first round in the medium term, the operators will be captains, navigators that have sailed, and they will be on shore. And of course, they will not feel comfortable because they're used to being on board. But the next generation operators in 10 years, they're going to be gamers, right? And if you put my son, who's 15, in the control room, he's going to feel pretty confident that he can do it. He probably will not do it very well, but you know, that's a different mindset as well. If you think really far away, you might not need the seagoing experience to be in the remote operation center, and your mindset will be very different.
Okay, Marianne, please.
Yeah. I just reflected on, based on the ongoing discussion, that these remote operation centers will probably gather the operation or monitoring of many different type of ships and activities with different type of manning levels and levels of autonomy, and that can in itself create a very different decision basis or need. So the traditional way is that when you are on board a ship, you take the decisions based on what you see, but in the remote operation center, you will need to consider much more complex environment where the roles can be kind of different seen from each ship. So that is maybe also a very interesting challenge to look into, how must the technology and the type of information you need, and what type of requirements do you place on the systems, that it will be closely interlinked.
Then Sanjay, I think we're rapidly approaching the end of the allocated time, aren't we?
I think we are Per, I thought we were until 6, but I'm guided by Per. But I just wanted to make a comment that Pierre mentioned that China has a lot of ships, but I know with 1,000 ships a day in Singapore waters, there may be an opportunity to collate all the data of all the photographs of all the ships that come here that could serve as at least the initial base load for these algorithms to start playing around with for situational awareness.
Yeah. I was thinking of the same thing actually with respect to the Sintef collaboration. Either half of the ships in the world would either go to Singapore or Norway. So you probably would capture all the world ships pretty fast if you had those two locations.
Thanks, Allan. Pia, any comments?
So many comments from me. I'm sorry, but if we could be sharing those data, right? Because now everybody has their own, every port has their own data and all the pictures and video footage and so on. If we could be sharing it in at least not a global scale, but in some cooperation form, it would be very useful. And also share the test results that are not going very well, because I think that's, everybody wants to talk about what's going well and show off, good results, but sometimes you learn something from failing. And if we could have more transparency also on when we fail in testing in various scenarios, autonomous ships, that also could really help us progress. So if we could start with the sharing of some data and also failed trials, that would be super useful.
Yep, Per Christer. Now I think we need your guidance on where we are with respect to the program and.
Sure.
Yeah.
No, we set aside 3 hours, so we do have until 6. But I think we have covered this pretty well. I really appreciate the good guidance from you and Sanjay. First, to have the quite complementary presentations. With still a big part of overlapping interests, and then this discussion afterwards. The question, of course, that I'm personally interested in is also how do we take this further? How do we actually cement a collaboration? And I posted one question to Marianne and that goes to I think Thomas, perhaps Sanjay as well, or Professor or Professor Cho. On how is it interesting to make center-to-center collaboration? Marianne, do you have? I mean, you're starting in December. Do you have made any thoughts of how you connect to international partners and collaborators? I'm thinking in terms of joint research projects, even funding, but also student exchange, PhD, joint PhDs, etc. Do you have any plan for international collaboration? This goes to Marianne first, and then to.
Yes, I can answer yes on that. As part of the preparation of the center, we identified, at least as a starting point, some collaborating partners, but that is also only an initial stage. So this is definitely something we can keep in touch on and see, to maybe follow up with an additional meeting together to explore some of the opportunities. So it could be, as was mentioned, on initiating what we call associated projects related to the center on topics where we share common interests, but which are kind of formally on their own, but they have an intersection to existing activities. But exchange of students, having some common workshops on topics of common interests. There are many opportunities, so a collaboration can be at many levels. So I would suggest that we could have maybe a separate follow-up on that.
Yep, we'll do that. I can take the initiative to put that together. And I'm thinking, well, Sanjay and Thomas maybe correct me, but maybe the COPS or even the Professor Cho's Center on COE for NGP, to put it in a Singapore way of talking.
so COPS would definitely like to participate, as evidenced by my.
Oh, there you go. There you go. Okay.
The good collaboration spirit.
I was just thinking. Yeah, I was thinking.
One of the areas that would be definite was listening to Thomas, where they are doing a lot of work through living labs and regulatory sandboxing, but are naturally limited with respect to sea area to play around with, without interfering with the present quite busy operations. So there could be that possibility of using the wider sea space or the uninterrupted sea space around Trondheim or other places in Norway as well. So there are definitely areas where I think we could have very nice synergies from working together.
Yeah, and maybe I could add, I think, there are a lot of Norwegian companies also here in Singapore. I mean, Kongsberg is well represented here in Singapore. We have the MPA RCN MOU framework that's been established for the last 20 years. So there are the different instruments and conditions where we should facilitate cooperation between the two research areas and the industry needs. So it's just not the universities and the research centers that need to put their minds together, but we have an engaged industry that really wants to push this envelope on all the development as well, available not only in Norway, but they're also located in Singapore as well. So there's a good reason why, if with all this in place, why we can't take off, because in many places you don't have all these different moving parts all sitting together, and we do. So it's just a question of us getting together and doing something, I think.
It's very true. And when it comes, I mean, when we're trying to put together a research collaboration, the interest is there, and the discussion very often ends in lack of funding. And the funding organizations, the Norwegian Research Council and the National Research Foundation here, are aware of this. And it's not lack of interest or willingness. It's what they want is a bottom-up approach. They want to see real projects. They want to see tangible projects with tangible outcomes, with tangible structures. And if that comes up, then they are very willing, I think, to look into funding schemes, rather than starting from top down by having a formal MOUs between institutions and then try to find something that fills into these MOUs. So they are asking us to specifically come up with projects, concrete projects. And I think within this space, there should be many. One of the areas that I kind of a little bit picked up is what I think it was it Marianne mentioned, the need for data sets for training of AIs or machine learning, and the basis for that. I mean, Singapore has one set of data, which is for your port operations, which is very unique and a massive amount. It could be valuable for Marianne's training of your autonomous vessel. And the Norwegian approach to this, referring to PIAs, is to replace land transport on short distance shipping. That's a different kind of data sets, a different kind of approach that could be valuable back to Singapore. So together you have a bigger database, you make a more holistic approach, and you can even match the Chinese databases perhaps. So there's a collaborative things there. It's a complementary and collaborative opportunities by sharing the data sets, so the training sets as well.
Thomas, you had your hand up.
So one of the way to access some of these data would be through projects. So I was hoping the research community can plug into the projects that Kongsberg, DMV and other Singapore companies are doing. If you're plugged into the projects and they face some of technical challenges that they want to do R&D, and that's where you can really get a hands on the data from there. And from my perspective, myself and Sanjay will be quite keen to see how next year we can organize workshops of all the key companies that are involved in all these maritime autonomy developments to understand their R&D challenges and whether some of these challenges they can actually translate it to the research community to undertake. Then it becomes it complements our current ongoing efforts where there are already existing efforts between universities here and Norway doing some bottoms-up research. I think that is useful, but we want to really complement that with the industry inputs to drive some of these research towards mission-oriented outcomes. Yeah.
Yep. Pia, please go ahead.
I love it when the kids come in the background. Yeah, it's so nice to see. My comment was around further collaboration with different companies that are also commercially vested in autonomy. That on the safety and acceptance level side, we should all cooperate, like the oil industry has done for years. You know, we should not really compete on safety. So that's one area where we could all be more willing to share data, I think, than on business models or revenue models and so on. And the other part, which I really like, Thomas, that you said earlier, is on the cost side, because we know that technology can be developed to handle most of the issues that we see, but we don't know that it can be affordable, and it needs to be affordable for people to start adopting actually get to this better safety level and better CO2 footprint of our transportation industry. So to make it cost efficient, it should actually be much higher on the agenda than it is today, also as a research question. So I hope that can be raised further up. Of course, standardization, modules, mass production, all of this will help, but in general, making it affordable and still safe. That's a key challenge.
So maybe if I can jump in there, one idea is it was pointed out that, you know, there are 6 billion cars, but there's only 60,000 ships. So is there an overlap of technology that can be mapped over from maybe aerospace, well, as the automobile industry for use where they've already done the R&D to develop some of the systems and some of the know-how methodologies? So I know that has a very strong aerospace industry and research component here. So is there a connection that can be made to bring in some of that know-how to sort of give us a leg up as well in the marine side?
Yeah, it's an interesting question. Yeah. I definitely we need to explore outside our own very comfortable, well-known box, at least. But how to do that in reality? That's a good question. Thank you.
I mean, I don't have the answer either, but I know, for example, there was just a discussion going around in NUS about licensing for remotely operated drone pilots and what were their requirements for that. And so it just occurred to me that maybe there's a connection there with our own work in terms of autonomy. What are the qualifications for a remote pilot? Are similar to the drones now?
Actually,
it's a very, very good point, because we tend to think that we're so unique in the maritime industry. Of course we are, but there are certain synergies, especially thinking about shore control centers or remote operation centers in other industries. There's a centralization going on there as well. There's, you know, flight towers in Norway that are covering total different areas and so on. So it's a gradual development. Definitely. But I think that for both the car industry and the airline industry, in terms of cost, it's been more like, okay, this is the maximum that this can cost. How can you deliver that? While we have on the other side been very much like, okay, how can we make it smart enough, or like, you're going to make this super smart vessel and extremely safe, and then the cost is just like crawling. Maybe the challenge should be, what can you make? How smart can you make something if it's going to cost X amounts? That's also an interesting challenge.
Great, inverse
solution.
What can you do for this amount of money?
But actually, I thought that one way to actually cross to other industry is to attend, you know, conferences. Like, for example, there's an intelligent transportation system conferences that is around, which also talk about autonomous vehicle and driverless vehicle. So at least to understand what's the technology that you use. There might be some synergies that maybe in the maritime space, they might also want to adopt this kind, or possible practically be able to use that kind of technology as well. Since I think in autonomous vehicle, it's also been quite advanced as well in this area.
Sure. Yeah.
Sanjay?
Yeah, just by way of information, actually the Nanyang Technological University has an autonomous vehicle research group, and they actually have a test site called CTRAN, where they work closely with the Land Transport Authority. So any autonomous vehicle, before you can actually go to the main road, has to actually pass a certain test that CTRAN actually runs for autonomous vehicles, and that's was a huge investment by the government to set up the track area for the training, and they also have algorithms, testing of the algorithms and everything on. So we have at least some autonomous vehicle experience down here in Singapore as well.
Yeah, go ahead, please.
It was Marianne first.
Okay, sorry.
Oh, yeah, that's not that important. But I would just like to mention that when it comes to transferring knowledge from other industries, I think that's very important. How so the opportunities that was mentioned is relevant. I could just mention for our SFI, we at least try to secure that also by going a bit deep into each area. So, for example, on the auto remote or the digital communication, the researchers that are involved there, they also work on other domains. So that is also a way to think that we connect researchers that are working in different domains and see how can we adapt that to maritime sector.
I also would just like to mention that in Norway we have a cluster called Sustainable Autonomous Mobility Systems, SAMS Norway, that Innovation Norway has funded. And there you have all the different players basically representing land transport, sea transport, anything. Like you have the autonomous snow removal systems for airports. And these guys doing this the snow removal, they also can move into ports. You know, why shouldn't they be able to deliver autonomous mobility systems or autonomous service systems for ports? Because it's quite similar to an airport. It's a restricted area, a limited area, predictable flows. So now we're starting to see a little bit of more collaboration across industries, which is very interesting. Also in terms of, again, coming back to the cost issue, that you have more you know, people and companies challenging the current business. That's interesting.
Is that where Peter Due ended up, in this snow removal company?
Exactly. So he went from he worked in Kongsberg Maritime with Autonomy. He was hired by Yara to when they started the Yara Birkeland project to really start. Yara wanted to go deep into autonomous unmanned and zero emission shipping, but now they kind of put that little bit on the side. They go back to their core, and now he started with the autonomous snow removal. Yeti move.
Yeti.
So it's
not a lot of call for snow removal in Singapore.
no, it's not snow removal in Singapore. But it's
Yeah.
can be, you know, it can be used in any kind of vehicle, of course, to perform any kind of cleaning of the roads. Then.
Yeah, we got a lot of leaves.
Yeah, you got leaves, and maybe some dogs. I don't know.
Especially during the fall season.
Yeah. Okay, I think we are now moving towards an end, perhaps. Thank you very much again. This was really a good session. I noted down a number of points and follow up on this. Please send me the presentations for those of you who haven't done it yet, and make sure that they are distributable, so we can distribute them to the other participants. And as I mentioned, this is also being recorded, so I will share this on a YouTube channel when my computer is back in good shape again. Just want to mention that tomorrow is another ocean focus day. That will be the last day of the Norway-Singapore Science Week. It's divided into 2 times 1.5 hours, where the first part is actually headed by Allan again, as one of the co-chairs, and Arne Fredheim. Which will focus more on ocean technologies. We're looking a bit on aquaculture, floating and these things. For the last session would be more on additional things. We'll have one session on sea level rise and the combination of the relationship between climate change in the Arctic and sea level rise in Singapore. How do you model? How do you assess? How do you simulate? And how do you, I wouldn't say prevent, but how do you prepare for this? And the second part would be more on law of the ocean. So be welcome tomorrow for those of you that have interest. If not, then thank you so much. I suggest that we round off the session now. So good evening to us in Singapore, and good rest of the day for you in Norway. And I think all of us are switching over to CNN just after this, I guess.
Yes, I think.
Pia, do you have some?
I
any
already
news?
switched on.
Oh, you have? Okay.
Okay, great to meet you all.
Thank you
Yeah.
very
Yeah,
much.
nice
Thank you.
See you
Yeah,
tomorrow.
good to see you
Bye.
again.
Bye-bye.
Bye.
Yeah.
Take care.
Thank you very much, everybody.